Recoders, welcome back. So this is our 15th assessment, and yeah, in the last assessment we solved this on-site interview one. So we have like three questions. One was on some stone problem, and another one was related to the hash map. So we have to basically it was a design problem. We have to use some kind of data structure to basically make sure that all the operations are optimized. So today let's go on online assessment. And let's see how it goes. Okay. So we have two questions. Let's quickly solve it, try to solve it, and see how it goes. Okay, so we have a string. Reverse only all the vowels in the string and return it. The vowels are this. They can appear in both lowercase and uppercase more than once. Okay, so we have a string here, and then I, E, E, A. So we have to reverse it. Okay. Yeah. So the question says like, you have this string. Okay, let me copy paste here in the editor and maybe make the space a little bit. Okay. Now see where are vowels? So our vowel is here, right? I, and then vowel is here, then one vowel is here, and then one vowel is here. Right? So I, E, E, A. Now what we have to do? We have to reverse only these. All other characters will be in their original position. We just need to make sure that I, E, E, A, instead of getting that, we're gonna get like A, E, E, I, right? So you see here, A, E, E, I, and all the other characters are at their original place. Mm, yep. So there are multiple ways to do it, I'm able to think. The very first thing, like I have to make sure that I'm able to check whether it is in a vowel or not in an easier way. So I'm just gonna write a small util method for that. Maybe like is vowel something like then I'm gonna receive a character and just return ch equals to a or I mean copy paste this. Maybe I can just say something like this. Um, cat equals to character dot to lowercase maybe. Otherwise, I have to check with capital A, capital E, capital I also. Now with this, I'm just making it into the lowercase and then I can check for small a, e, I, o, u. Right. So much just a easier way to achieve this. But of course, you can write also this capital checks also you can do. But I think this should work. So I can just say O and U. So this method is basically for checking any character is a vowel or not. Right. And then what I'm gonna do? Maybe I can just extract all these vowels into some character array and then reverse it. Can I do that? Um, y- yes. So the idea is, now let me show you what I'm thinking. So I'm gonna first extract all these vowels in their occurring order. So I will create a list maybe, and that will contain something like this: I, E, E, and A. This will be my initial list. Now what I'm gonna do, I'm gonna reverse the list. So now my list will contain something like A, E, E, and I. Right. So now this is what I will get. Now I will iterate over each of this string, original string, and check if it is a vowel. I will pick the element from my reverse list, the very first one. Right. So if you see here, I is a vowel. So I'm gonna pick this one. Okay. Then see it's not a vowel, so I will print like it is. So the first thing we go, so let me show you how I build my answer here. I can put some space and yeah. So I is a vowel. So let's go and pick my this one because I want the reverse order, right? So this is it. Or wait a minute, we can do even better. I just need to maintain two pointers maybe. One pointer at I and another pointer is at but I have to mutate it the string and can I do that? E and then reverse it. Yeah, I think I can do that. Okay. Yeah, this is another way you can do it, but more easier way will be just to reverse it. I mean, let me show you how. So I'm gonna create a character array out of this. So s start to char array, right? And then I'm gonna create two pointers. One is at the zeroth index, another will be the last, right? So idea is if you see this ice cream, right? So my first pointer is currently here, and my right pointer is currently here, right? And I have to make sure L and are at the vowel. So since here R is not at vowel, right? So I'm gonna minus minus. Now you see L and R both are vowel. So I'm gonna reverse it. So I and A will be reversed. So A will come here and I will come here. And then I will again make R to be here because this is a vowel. And I will make my L to be here, right? And this one to here. And then again I reverse. I will keep doing it and I will get my answer. So I think this will be easier instead of creating list and reversing and building. But yeah, that also we can do. But I think this should work. So I simply like while left is less than right. Um, and then with let's say char ch at left equals to s dot char at left, and maybe character at right equals to s dot um char at right. Now, if both of these characters are vowel, then we have to reverse it, right? So if is vowel, our method ch1 and is vowel, I have chr, okay, this chl. If both are vowel, then we have to reverse those. So let's do that. So char temp equals to chl. Mm, okay, why I'm using char at method? Okay, my bad. Since we have already created the array, I can just say like ch left, and this one I can say okay ch right, and here I'm gonna do something like this, right? Ch left, and then ch left is equals to ch right, and see simple swapping we are performing, right? And then I will make sure to increase my pointer, right? Minus minus. Now other things we have to check is else if not is vowel chl, then also make left plus plus, and else if not is vowel chr, just make right minus minus, and yeah, we're gonna just return this. We're gonna build this answer again. Let's create a string builder for that. Yes, okay. For c of ch sp dot append c, and then you're gonna return sp dot to string. So, so this I think this part will be clear. So you see here, whenever I'm at this vowel, I can simply just reverse it, and I will increase my L and R. Right? I will make sure my L moves in the right side and R move in the left side. Now, let's say if my L is here, right, at C. Now C is not a vowel, so I have to move this L forward, right? So this is what that line was doing. And let's say for if R is here, now R is pointing to this R. Okay, we don't need that. We want this R to be pointed to some vowel. So what we're gonna do? We're gonna minus minus it, right? So try to find the vowels and then reverse it. So yeah, I think this is the code. Let me compile it. See any compile time error? Yeah, we have. Okay, this one is not commented out. Okay, two attempt too soon. Okay, okay, we have an issue here. Okay, I have to use X, not six. Okay. Maybe I can do like C here and C is here and C here. Okay. So I think we are getting ACECREIM. Yeah, correct. Let me try submitting it. Yeah, we are able to. So I will categorize this one into like two pointer problem. So basically, we have one point. You create two pointers at the two side and try to do some operations. And after doing that operation, you just sync both your left pointer in the right side and right pointer to the left side, and you keep doing it. So I would. There's nothing any fancy data structure algorithm for this one, but yeah, two pointer you can categorize for this one. Yeah, let's move to the second question. This last day, I think I solved the tree problem quite fast, and I should have explained more better. Let's try for this one. So, given a root of a binary tree, return an array of largest value in each row of the tree. Okay, so here the largest value here is a 1, largest value here is a 3, and largest value here is a 9. Right. So the very first thing after only seeing this question, by reading the description, I can say here and where it is row, right? So whenever you see something like row, you have to do traversal or you have to do some operations row wise, you should know your level order traversal in a binary tree. So when you do DFS, so we have like different variations. Okay, let me show you how. So we have two way to iterate in a tree. One is a DFS way. In a DFS, we have in order, pre-order, and post-order. Most of the time, any of these work, but sometimes when you have a binary source, what we call like, yeah, most of the time in you can use anyone, right? And that will work to basically to iterate over all the nodes, all the elements of the binary tree. Another way is like BFS, you do for level order traversal. So you should know these two fundamentals, at least for the tree kind of problem. Now here it says, na, we have to do level by level order traversal, and we have to find the maximum element at each level. So here you see 1, here is a 3, here is a 9. Of course, you can solve it using DFS also. Maybe I can show you that, but more natural way for this one, it should be BFS. But I will show you how you can solve it in DFS also. But BFS is something you should try to do first if you are new to tree kind of problem. So what's the idea? Idea is we're gonna get this one, then we're gonna get 3, 2, and then we're gonna get 5, 3, 9. And for each element, we just take the maximum element and put it in my answer. Right. So let me show you how we can do that. Let me create that answer variable here. Return the answer. Okay. So whenever you see the BFS level order traversal, you have to use Q for that. And the idea is you gonna go to the first root, you're gonna put it in the queue, then the left child and right child also gonna be put in the queue, and then you're gonna pull all these elements from the queue one by side. Okay, let me show you here. It will be make more sense. So initially my queue will contain one, right? And then I remove this element. Since one is the maximum, one will be in my list of answer, right? Now one left child is 3 and right child is 2. So then the next step, my queue will contain 3, sorry, 2 or 3. It doesn't matter. You can put 2 first and 3 later. Now we have these two elements. Now we have to take the max, which is 3, right? In the next traversal, we're gonna have the elements of 5, 3, and 9 in my queue. And what is the maximum? 9. So 9. Right, so that's how we're gonna do level by level and just pick the maximum. So it's like very standard to create a queue. And then we need to create a queue of type. Uh, type will be tree node because we wanted to get the access to the left and right side. So let's do that. If you are not using Java or some, you have a other programming language, so you should know your generic, right? So here I'm passing my generic to bit. This is a queue that will accept the tree node type. We're gonna perform operations using this. You can create integer, boolean, right? So you should know your generic. Uh, and then initially we're gonna offer the root. So this is the one we have offered. Now while queue dot is empty, or maybe I can just say size is not equals to 0. So you see here, so at some time my queue will contain these elements. So I'm gonna pick all of these elements at once. I'm right and get the maximum. So maybe I can initialize maybe my max to be integer that main value, and then I'm gonna get the size of the my queue. What are the number of elements in my queue, and then maybe I can say something like while size minus minus greater than 0, or maybe you can write a for loop from 0 to the size and keep extracting the element from the queue and compare, try to maximize it, right? We want the maximum thing. So like here I can say like current element in my queue is, I'm just pulling it from the queue and I'm just doing mx is equals to math dot max of mx current dot var. So let me show you here. So initially I get 5 and I have initialized my answer to be the minimum value, a very low negative value. So 5 and those negative value, which is bigger, 5, right? So now my 5 is my maximum. Then we go to the 3, 3 and 5, which is the maximum, 5, okay. 5 and 9, which is the maximum, 9. So that's how we are doing here. Um, so yeah, this is it. Now we also have to make sure that all this left and right child for this current is also going to add it for the next level, right? So let's do that. If current dot left is not equal to null, just add it into the queue. Um, current left. Similarly, if current dot right is not equal to null, queue dot offer current dot right. And yeah, after this, while loop, whenever we come outside, we have that and the mx will contain the maximum value in that level. So I just need to add it my answer. And I think yeah, this is it for this one. Maybe compile time errors. Let's see. We have okay. I am using try node. Why? I have to use linked list implementation. Let's see. We have any error? No, we don't. So 139. That's fine. Let's try it. Okay, I'm getting null pointer exception. This is weird. It says because my current is null and I'm trying to. Okay, but why in the first place I got null in my queue? Okay, my bad. So you said I didn't see the constraint. The constraint say the number of nodes in the tree can be ranged from 0, right? So when the root is null, I'm putting null in my queue, right? And then I'm putting this operation and null dot something, it's giving me like null pointer exception. So we just need to make sure one check. So if root equals to null, right? Meaning we do not have any tree, just return the empty answer, right? So this answer will be empty, just return it, and they should work. Mhm. Um. So yeah. BFS, right? So for BFS, you should know, I mean, for this question, I think you should know Q also, basic operations on the Q. And initially, it all doesn't make sense if you are, like, I will be very honest, right? So, like, whenever you solve three kind of problems, you will see, I mean, it doesn't make a lot of sense, but when you keep doing it, it will eventually click, right? So here now you see the idea. So initially, the very first time my queue is containing this root, which is one, right? And then I'm processing it. Then I'm putting in the queue three and two, and then processing three two. Then three all the child, five and three, and two all the child nine. I'm putting into the queue and processing. So whenever you see like row wise traversal, you should use the BFS. And BFS is mostly using queue. You will even the in the graph or the Dijkstra algorithm you do, or there is like what we call, there is one more algorithm. I don't exactly remember the name, but yeah, whenever you sort test kind of thing, so BFS is something you can do. Now, can we do it using DFS? I think we can do that because you see, we just have to maintain the level, right? So this is level 0. Whenever we move left call or right call, I can just maintain a variable that will contains like the next level, right? So this is 0th level, then I will come here, this is 1th level, and then come, this is the 2th level. And maybe I can just compute the answer for each level. So if you want, I can show you. Um, do we have time? How much time we have? I think it's been 20 minutes. Okay. Okay, let me show you. Let me show you for DFS version also. Um, yeah. So for DFS version, first thing I have to do, I have to write some weird stuff because DFS, DFS, DFS. Mm, so this is 0, 1. This is level 1. This is level 2. This is level 3. Mm, okay. So the idea is for DFS is we start from the 1, so this is level 1, right? So for the level 1, my answer is 1. That's fine. Then we go to the next level. Whenever we call DFS, the recursive call, so DFS root dot left, we come to the here. I will increase my level from 1 to 2. Now at level 2, do we have any elements already? No, so I'm gonna put 3. Then I will call my DFS again. I come to the 5. Now level becomes 3. Do we have anything at level 3 that is greater than 5? No. So initially my answer will be like 1, 3 and 5. Then I will come back and I will go here also. So in this level, what is this level? Level will be 3. And is 3 greater than 5? No. So 5 will be in my answer for the level 3. I will go back, go back. Then I come here. Is 2 greater than 3? No. So, okay. Then I will go to the here. Is 9 greater than 5? Yes. So I will update my answer from 5 to 9. I would suggest if you are comfortable with BFS, go with it. But if you just wanted to learn this one also, you can do that. So let me show you. I can just say DFS root and my initial level is 1. Okay. Then let me write this DFS 3 node root, and this is my current level. Now you see, if answer dot size is less than my level, I can just put this root dot val in my answer, right? Because I'm doing the what we call pre-ordered DFS. So I go to the one, okay, and my answer is still not initialized anything, so I'm just putting that into value, and then I will call my DFS left and DFS right. So DFS root dot left and DFS root dot right. And I also need to increase my level by 1, right? So level plus 1 and here also level plus 1. Now here it is the case when answer is not size of the level, but if we have already, so I can just take the maximum of it. So I can just say maybe okay, I mean this is not good because I should have used map maybe. Yep, yep. Otherwise, I think this should also work. Yeah, I think this should work. So initially, I will add 1 at level 1, 3 at level 2, and 5 at level 3. Right. And then when I come back to this 9, now we already will have 5. So I have to update because now 9 is greater than. So I'm gonna get the index. So level minus 1 because if level is 1, we are talking about the index 0, right? 2 index 1 and 3 index 2. So I can just say maybe list dot sorry answer dot get idx. This is maybe temp, and I can say if okay, miss the semicolon. If temp is less than current value, then I can simply say answer dot set idx to be root dot value. So this is like this case. So we already have at level 3 5, but now we have level 3 9 also. So I'm gonna update my level 3 to 9 because 9 is now bigger. So I think yeah, this is it for DFS version for this one. I think this should. Do we have anything? Okay, base case. So if root equals to null, we gonna just return, right? So initially, if null, we're gonna return. Otherwise, we come here. I will add my answer. I will call, and otherwise, I will idx and then get the value. Yeah, I think this is it. Let me try compiling it. Okay, we have, yeah, we have to return also. So let's do that. Yeah, we are getting easy 139. Let me try. Okay, before submitting again, I will do if root equals to null like we missed in the earlier version. So let's return it, submit it. Okay, I don't have to return null. I have to return the answer here. Yeah, I know that. We have to return the answer. So this is also working. Yeah, you can go. I mean, if you're new, I would say for row kind of problem, use BFS. Whenever you're comfortable with DFS, I generally like DFS because it is very cleaner. So yeah, whatever feel comfortable, you can do that. So thank you so much for watching. So we saw like these two questions. And the first one was two pointer, yeah, and that for this one we solved using both BFS and DFS. Maybe I should try one with a iterative DFS also, maybe. But 30 minutes now. We already been late. So I think yeah, these two approaches are enough. Let's see. Let's catch up tomorrow maybe and see how it goes. Thank you so much for watching. Have a nice day, evening, night.